welcome to the Convex Conversation with me, broadcaster Helen. This week, I'm just outside Munich to get an insight into the future of high-speed electric aviation. I've been invited by German aerospace company Lilium to be the first British journalist to take the pilot's seat in their simulator and experience what it feels like to fly the world's first electric vertical takeoff and landing jet known as an eVTOL. Some of the finest minds in the aerospace world are based here, designing a jet which it's hoped will revolutionise the way we travel regionally, as well as being clean and sustainable. The Lilium jet is all electric, designed for up to 6 passengers, travels at more than 250 kilometres or 155 miles an hour, and is 20 times quieter than a helicopter or business jet. Daniel Wiegand pioneered Lilium's aircraft architecture while studying aeronautics at the Technical University of Munich and co-founded the company in 2015. And it's a real privilege to be at Lilium's headquarters to look round with Daniel, get a taste of what vertical takeoff and landing feels like, and hear the story of how this incredible jet was born. Daniel, it's such an honour to be here at Lilium headquarters. A few weeks ago, I flew in a Spitfire simulator, and wow, the contrast today, stepping into your simulator and flying over London, flying over the Houses of Parliament and the London Eye, in what felt to me such a quiet, clean, simple, beautiful structure. It's difficult to put into words, really. It was absolutely amazing.
Hi, Helen. Well, first of all, welcome here at the Lilium headquarters. It's a pleasure to speak to you. What's the question?
Yeah, well, there was no question, really. I think I was just having a moment about what it was like in your simulator. What does it feel like for you when you get in there? I mean, to me, the simplicity just struck me. I had to actually ask, we've already taken off. And I realised I'd already lifted up. It's quiet and beautiful and straightforward. Describe it for us, Daniel, because I just went on a little ramble then because I was overwhelmed with how amazing it was.
Well, the simplicity and the cleanliness of an electric aircraft is what always intrigued us as well from the first day when having this idea, because you have a basically computer-controlled airplane. You don't have ropes going from your stick to the rudder also. You have a joystick in the cockpit where you command the aircraft's direction, and then a computer translates those commands into the complex steering of the aircraft for you. So it does exactly what you want in an incredibly simple way. And that's what you can feel when you are in the simulator.
So tell me the story behind Lilium and the beautiful jet you're developing here. How did it all come about?
I've always been passionate about flight, even as a little kid. My pets had to be birds. I was building radio-controlled planes when I was 10, 11. When I was 14, I begged my parents that I can start doing a gliding pilot license. So I was flying for the first time in my life alone in an aircraft when I was 14. And the feeling was amazing. You sit in this airplane, you know, you have to rely completely on yourself and bring this thing down safely. But I was singing, and if I could have, I would have been dancing in the cockpit after the takeoff. And so my approach to aerospace initially was very intuitive, more like kids approach things, like you do bicycle, you learn running a bicycle. And then later I studied aerospace engineering at the Technical University in Munich. And after 4 years of studying, I applied for my exchange semester, a classic Erasmus student semester in Glasgow. But I was kind of in a crisis with engineering because I had spent 4 years calculating dry calculations and finding solutions to things that other people had solved before. And I'm not the kind of person who can sit still for very long and listen to a lecture. It's just not my character. I need to do things. So I had a crisis with engineering and thought I need to widen my horizon, see something else, and enrolled in architecture and politics in Glasgow. And after a few weeks meeting incredibly exciting people and learning a lot about politics and architecture and perception of products and so on, I kind of started missing the clarity of the scientific world and the clarity of engineering. There's right and wrong very often. And I watched videos on YouTube of a US military vertical takeoff and landing aircraft, which was called V-22 Osprey. And I thought to myself, really within seconds, if you could do the same thing in an electric aircraft and make it smaller, you would have a perfect means of transportation. It's fast, it's clean, it would be very low noise and comfortable. It would be saving tons of time to everybody using it. And you don't even need an infrastructure on the ground like rail tracks or highways or so. You just need a helicopter pad to take off and land vertically. So that thought really happened within seconds, I would say, that suddenly a couple of bricks came together sitting in front of me, and here it was. So after that, I got very excited about this idea and started calculating, is it technically possible? And what I found was basically, it's just about possible. It was on the edge at the time with the technology and batteries available to make something like this work. And then it was my flatmate who came in after 2 or 3 weeks and said, "What are you doing here?" I explained to him, and he was the one who said, if it was the most normal thing in the world, if you think that's technically possible, you should found a company and do it. And for me, that was outrageous. I'm a student. Why would I found an aerospace company? But we had some beers on that night, and I shook hands with him and promised him I would go back to Germany and do this. And from that moment onwards, which was end of 2013, I had a mission. It was very clear, you're going to finish your aerospace degree. You have a purpose for sitting in the lecture now. And I was always very good in engineering lectures and exams. That wasn't the problem. It was just that I was missing that purpose. So now I had a plan. Went back to Germany, didn't tell a lot of people because I felt almost a bit ashamed of the craziness of,
Did you really?
Of doing this. Yeah, I was afraid people would try to talk me out of the idea. And so I went to a friend of mine, Sebastian, here in Munich, and in an 8-9 hours walk around the city, I convinced him that he would join me in founding that company. And he just had started his PhD at the TU Munich. Then a friend of him joined, Patrick, who was known to be one of the best aerodynamicists, also in a PhD. And then we said we need one more who brings in all that robotics and software and avionics knowledge. So we went into the robotics department and just casted Matthias, our fourth co-founder, into the team. And then when Matthias joined, it took about 6 or 8 months until we were ready to found the company, because we basically had no money. We had to get bank loans and get some grants from the European Union. And in the first 12 months went on like this, bootstrapping the company, building a first full prototype of 3 meters size with a hacked quadrocopter drone computer and 36 little electric engines in there. And then we got the first investment from a real investor.
And here you are with 800 employees from 58 different countries, 6 continents, and I would imagine some of the finest brains in engineering and aerospace that exist.
The company today is incredible. And honestly, at the time in the beginning, I didn't even dream about having a team like this, because it's the most experienced people in aerospace. Head of engineering from Rolls-Royce, the program head of the Airbus A320, the chief quality officer of the Airbus A350, and about 400 aerospace engineers underneath. But the company wasn't always like that. In the beginning, we were more like young cowboy engineers, a classic Silicon Valley company, breaking things fast, moving very fast. And we had to, because we had to use very little money and take that money to prove fundamentally that the physics and technology work. So there was not this sophisticated quality management in place. It was rough engineering. And in 2019, we had a 1.5 tons 4-seat aircraft flying here in Munich. For the whole summer, it was flying very nicely. But we were just at the point saying, now the technology is ready to start designing the commercial version of the aircraft and go away from the prototypes. And at that point, we had a fire in the hangar, losing that prototype.
Oh my goodness.
We lost it not because it was a bad design or so. We lost it because we were not an aerospace company. We had no maintenance instructions. We had no manuals. We didn't have documented design data. So a mix between human factors and that lack of process in the end led to a battery fire during the maintenance of the aircraft. And it was damaged so much that you couldn't use it anymore. And in retrospect, that crisis where I personally was thinking, okay, in that moment, I was thinking it's the end of the company. And yet you have to stand in front of your team and tell everybody the way forward and have a way forward in your mind. But in retrospect, it was one of the best things that could have happened, because we realized we got to rebuild the whole company, transform from a Silicon Valley cowboy type startup into an aerospace company that is capable of making products that are as safe as the airliners we know today. So we started to hire all these incredibly experienced people into the team who have certified aircraft, who have built a quality management system, who bring in decades of experience throughout their careers. And this is the main reason why I today have 100% conviction that this team will deliver a certified aircraft.
What was the moment when you knew that the technology and physics was actually going to work? Was that in the early days of the company?
It may sound a bit crazy, but I was convinced on the first day that it technically works, because as an engineer, you learn what's behind the formula you use. It's very validated physics, and you trust that 100%. So if your calculations say that it's going to work, it will work. But still, there's a very long way from theoretical feasibility, just adding up forces and energies and moments, into an actually working product where you're dealing with the devil in the detail. It's a very long way.
And what was the moment like when you flew the first prototype? Can you remember the emotions that you felt that day?
I think it was the strongest emotion we ever felt in the company when that 1.5 tons prototype took off. We had smaller aircraft taking off in the past, but that 1.5 tons aircraft was a totally different beast. It was real life, full size. And we had spent literally days and nights for 2 years with a very small team to make that aircraft fly. And it was the first of everything, the first vertical takeoff and landing electric aircraft. It was the first electric jet. It was the first of that size for the company. And when it took off, there's a nice video which you can still find online where the entire team jumps up off their chairs and is crying, like shouting, celebrating, and it just lifted off by 2 meters or so. But it shows you the pressure which was on the shoulders of every single engineer and the whole team, all the hard work that went into it. And everybody knew if it lifts off, it'll do the rest, like intuitively.
I have the benefit of not only flying your simulator this morning, but spending some time with your full-size, I don't know what you call it, your prototype, full-size replica of a prototype. The show jet.
Full-size mock-up.
Full-size mock-up. Of course, this is an audio podcast, so for the benefit of people listening to this, can you describe the jet to us in your words and also in kind of layman's terms, although we have a lot of aviation experts who enjoy the podcast, so not too much layman's terms, explain how it works and the theory behind the vertical takeoff and landing?
It's an incredibly elegant design, I would say, both from an aesthetic point of view. That was important for us, growing up between Porsche and BMW, Audi, Mercedes, etc. But at the same time, it's very elegant in its simplicity. So it's got 4 wings, 2 small wings in the front, 2 large wings in the rear, and it carries engines which can pivot on the trailing edge of each wing. And these are electric engines. So it's a simple aircraft in a sense that the electric engine has only one moving part. It's the same principle like a hairdryer, basically, but very powerful. And the aircraft has only 2 functions. It can spin the fan in the engine to make more thrust locally, and it can pivot the angle of the engine. And then the software control in the computers is translating your stick command as a pilot into different angles and RPMs of these different engines. And that means there's no aerodynamic control surfaces on the aircraft. There's no tail that stabilizes the aircraft. It's all done by that thrust vectoring software control of the airplane.
And the simplicity was really important to you, wasn't it, in the design?
Absolutely. I mean, Elon Musk always kept saying the best part is no part. And there's no field where this is more true than in aerospace, because you want to save weight. You're always on the cutting edge of performance. You need to have something that's very safe. And no part means lower cost, lower weight, can't fail. So it's better safety. And in the end, this simple architecture with all its synergies makes the aircraft more performant. And that's what really mattered to us next to cost and safety. We wanted to have an airplane that can fly regional distances with the incredibly small amount of energy in a battery. They store way less energy than you have in kerosene, for example. So you have to make an aircraft that is more efficient than traditional airplanes. And that's why we don't have a tail. That's why the engines are embedded into the wings. This is why we try to reduce the weight so much through this simplicity. And I think it's been very successful so far as a design throughout the flight testing, going from 0 to the maximum speed over the last 2 years in flight testing.
And the simplicity as well of taking off vertically. How did that idea come to you? And was that back at the university days when you were coming up with the whole concept? Because when you've experienced that, it seems ridiculous that in a small aircraft, we now have to have a long runway. Your aircraft can take off on what you'll call a vertiport, which is something the size of really a helipad.
Yeah, I mean, the vertical takeoff and landing airplane is a very old idea.
Is it?
And the British have the Harrier. So
of course.
One of the most successful vertical takeoff and landing airplanes was invented in Britain. And we do the same in an electric version. However, the electric powertrain has a few unique advantages to do something like this. If you look at the Tesla car, for example, they have incredible acceleration, incredible power density. And that's because an electric motor for a short period of time can deliver 3-4 times more power. So you can heavily overload it. And we utilize that capability for the vertical takeoff and landing of the aircraft. But at the same time, we still have very light engines on the airplane, because in cruise flight, they run at 10% of the power compared to takeoff and landing. And this makes a vertical takeoff and landing airplane with an electric powertrain simpler and more capable than with traditional propulsion technologies. It's really the battery and the electric motor that enable this class of an aircraft now.
And of course, a lot quieter. We said in the introduction, I think 20 times quieter than a helicopter or a business jet. And if you're transforming regional air mobility, that's really important, as well as the cleanness of using electricity, isn't it?
Exactly. The main reason why helicopters, which can take off and land vertically already, are not widespread in use is that they're very noisy. Communities mostly don't accept them. And they have a safety issue because there's single points of failure, as the engineer would say, which means if you lose one part on the mechanics of the rotor, the helicopter is lost. And in traditional aerospace, in commercial airliners, you have certification requirements to have redundancy on all the functions across the aircraft. And that's what makes airliners so safe. It's one of the big aspects. And this concept we could transfer into our aircraft. There's no single point of failure. You have redundant engines, redundant computers, 10 redundant batteries, etc. And we're certifying it against the same safety standard like an airliner. So we solved the noise problem, we solved the safety problem, and we achieve lower operating cost, because the battery powertrain requires much lower maintenance and electricity is much lower cost than traditional fuels.
And in the world we're living in, Daniel, living in a climate crisis, presumably the sustainability aspect of it is absolutely key to this.
Absolutely. For myself, for the co-founders and the entire rest of the team, if you would interview people here in the company, that's what motivates them. They are engineers, but they follow a purpose. And that means we invested more than €1 billion so far into this technology of battery electric jet aircraft. And the Lilium jet right now is the only commercial electric jet in a certification program with the regulators. But we have the plan and the intent to utilize this technology, amortize the investment over multiple platforms and larger aircraft. We couldn't initially start with a 50 or 100 seat electric airliner. It's just too big of a step in terms of funding, in terms of regulation, in terms of technology. But we can utilize the smaller airplane, build a company that has the capability, build a supply chain, establish the regulation with the regulators, and then take that whole capability and make larger conventional takeoff and landing jets to do regional flights and regional connections entirely battery powered, completely clean, same low noise features, and feel better in flying. Because we feel bad very often today, knowing that we emit so much CO2, and we got to change that. And I think this company is best placed to do that.
Although the jet, to me, looks quite futuristic, it's not futuristic. The technology is here now. How long, roughly, do you think it will be, Daniel, before eVTOLs are a fairly normal sight and people are used to seeing aircraft flying like that. How many years away are we from that?
For this to be part of the everyday life, it's at least 10 years out. We intend to certify the aircraft and go on the market end of 25, but then you have one aircraft and 10, then 20, and the planet is big. So there's a whole industry, there's other companies making electric aircraft next to us, and there's enough space for all of us. You have to have many companies, a big aerospace supply chain to be producing for a decade or so to make this a widely adopted and normal appearance in our life.
But we all know how quickly time goes, and a decade isn't actually very long, is it?
Yeah, I think humans tend to underestimate exponential growth. We just can't grasp it. And it is exponential growth when it gets picked up. So initially, the first 2 or 3 years, you're going to feel like, yeah, there's some flights in big cities which are well known, but it's not everywhere in the countryside. And then a few years later, suddenly you can fly in the countryside of the UK and book a ticket on one of these airplanes.
Fantastic. Tell me about the testing process. I gather at the moment there's some testing going on in Andalusia in Spain. Tell me how that's all going and what kind of speeds you've achieved and what goes on with the test side of things.
So we pursue a very classic aerospace program in which we do what we call evidence-based engineering. That means we have a whole digital modeling and simulation-based development part, and we try to calibrate and validate those models and simulations with real-life testing. And we do this on all the levels of the airplane, from the small component where you have a compressor test for the fan of the engine. You do this on engine test rigs where the whole engine comes together. And then finally, King's discipline is flight testing. And we have for almost 2 years now in Spain a flight test team testing that full-size real-life aircraft. And this testing helps us to go back and validate all the models of flight physics, of aerodynamics, etc. We also do wind tunnel testing a lot with full-size wings, engines. We have right now an entire Lilium jet in a scaled version in a wind tunnel here in Europe, which runs for many weeks through a characterization. And in Spain, we've been testing over the last 12 months all the major parts of the flight envelope, as we call it. So the maneuvers the airplane can fly, vertical takeoff and landings, then the transition flight from the hover into the forward flight, the high-speed flight. We've relatively recently, we've tested engine failures, we've tested the ground effects. So when the aircraft comes down and blows on the ground, what do the vortices and winds it creates by itself to the control software? We've tested noise, and noise is always impressive. We had a TV team over there who flew a very long way to come to Spain, in the middle of Spain where there's nothing. And the cameraman missed the takeoff because he thought he was standing 50 meters away from the aircraft. And he was thinking, this is idle, they're doing some ground checks or so, and suddenly the aircraft lifted off. And the journalist wasn't that happy.
No, I'm sure I wouldn't have been very happy if I'd been the journalist if that had happened.
But for us, it was the biggest compliment they could make.
Well, that was a bit that happened to me in the simulator. This morning, I had to ask Andreas whether I was actually flying. I'd taken off so quietly and seamlessly, I didn't really realised suddenly I was airborne, which was amazing. And at this stage, your test pilots are on the ground. They're not in
Exactly. So the Spain aircraft is remote controlled.
Yeah.
The main reason is that it saves us a lot of time. If you want to bring a pilot into the aircraft, you have to do roughly a year worth of engineering and testing to demonstrate the safety of flight and to get a permit for a manned flight. But that's exactly what we're doing right now. We have, and I can give you a bit of an outlook what's happening in the next 2 years. We have right now the composite frame molds in production for the airframe of the certification aircraft. We call it the conforming airplane in aerospace because it's conforming to the design data and to the regulation it needs to comply with. And the fourth quarter this year, we will receive the fuselage and wings in the final assembly line and start assembling the first of these conforming airplanes. Then there's going to be what we call an iron bird on the ground, which is actually a composite bird. It's an airplane that stays on the ground, which carries all the systems, and we can do integration tests of that airplane. Then there's going to be ground tests of the later flying aircraft, where it's tied down to the ground and you do the last checks and tests. And then in the second half next year, we're going to have the first piloted flight in the certification aircraft. And then there's about 1.5 years of flight testing with 6 airplanes, similar to what you typically know from airliner certification campaigns. And then the target is end of 25 to obtain the commercial certification for the aircraft and deliver to our first customers.
And do you know who that first test pilot will be already? Is that person already working for Lilium?
Yes, I think that person is here. Our chief test pilot is actually a bit famous. He flew the helicopter in the James Bond Skyfall movie.
Did he?
The helicopter that I believe destroyed Bond's house. So I'm sorry for that. But he's an amazing pilot. Yes.
That sounds like there's a podcast part 2, actually. You just revealed somebody else who would be great for our series, I think.
You should speak to him.
I'm sure he has some great stories. And for you, gosh, what a long way you've come from being that small boy building your own remote little aeroplanes to watching the prototype being tested remotely. I mean, what do your family think about it, Daniel?
I think we're all very humble. I mean, it's not one person building this. There's 850 people here in the team. And as I told you when we were walking here, one thing I realized is that most things on the planet you don't know. So it's the most impressive thing for me is to see all that knowledge in the team, to see all these decades of experience coming together. And you need that to be in place to make it work. It's really a team effort.
I've been following you on Instagram for a while, and one of the films that you released recently, which I thought was particularly beautiful, was the one which featured the Harris Hawk flying. Where did the Harris Hawk connection come in and that kind of symbolism?
Well, the idea we have, the mission we have as a company is to enable everybody to fly regional and electric and experience those benefits in a lot of societies around the planet. And birds are the best example of democratizing flight, right? They can all fly. And the Harris Hawk is basically an eagle that flies in Spain where we are flight testing. And the engineers are always watching the hawk. When the hawk is there, there's updrafts, there's a certain type of weather. And as an engineer in aerospace, you always try to compete with birds, knowing that they are always better than you are because they can swim, walk, fly. They have incredible flight capabilities. So I think there's this emotional connection. If you're a pilot or an aerospace engineer, you're always looking at the birds.
So long term, sitting in the aircraft today, what struck me was its simplicity, but it felt like being in a very beautiful private jet. It had a luxurious feel about it. Is this aimed at kind of normal people so it can be almost like a regional taxi?
The mission we always had in our mind, we wanted to make it affordable to people, and that's incredibly difficult. But what we have achieved is the aircraft we're producing now has the largest cabin in its segment. If you want to compare it, it's a 3 tons aircraft and it has a cabin size of a 5-6 tons helicopter class, which is 2-3 times more expensive than this aircraft. And we need that large cabin to bring more people on board and make those shuttle flights more affordable. So there's this idea of an air taxi which goes around the planet for a couple of years. We've never really seen ourselves as an air taxi flying 10 miles across a city, because you don't save a lot of time there and you typically have 1.5 passengers on board. We were instead of that always looking at flying regional distances, connecting cities to other cities, and that enables you to save hours of time. So it makes much more sense to switch into an aircraft, but it also enables you to bring more people on board and share the cost of the pilot, the landing fees, the maintenance cost over more tickets and bring down the cost. So initially, we're going on the market still with a very premium version, very similar strategy to what Tesla have done. You start in the premium segment because you can charge higher prices when your production volume is low and you get better margins there. We have our first customer actually in the UK. The name is eVTOL and they have pre-ordered the limited edition, the Pioneer version of the aircraft that goes into that premium segment where we basically utilize the size of the cabin as a premium offering. But then over time, we intend to reduce the costs, ramp up the production rate of the airplanes, and then go into that shuttle market where we see 90% of the market size and the amount of airplanes to be shipped into.
I was going to ask you about what appetite you'd had from the UK. And it's great that you've got, one of the UK's largest helicopter and private jet companies, a subsidiary of them, already interested. I gather they've purchased 10 with an option for another 10. They're based in Oxford, aren't they? That must have been a very exciting contract for you to sign.
It was amazing. Dustin is an amazing entrepreneur, the founder of Evolare. And for me as a founder, it was an amazing feeling after 7-8 years of working on this aircraft to see incredibly excited customers who are willing to put down real money to pre-order the airplane that doesn't yet exist. It's still in certification and production. And the trust that comes with that means a ton to me and to everybody in the team. We've been pursuing a strategy over the last 2 years to be very transparent to our customers with the successes, but also the challenges we have in the program. Because when you design something new with new technologies and regulation in flux, you don't have the predictability of a classic aircraft program where Airbus can predict with 0.5% accuracy the fuel consumption of their airplanes. We had 10% inaccuracy or more because everything was in flux. And making this transparent to the customer and taking them along the journey, I think is what matters to both sides. And it's an incredible feeling for me to have now a total of 600 pre-orders or 640 pre-orders for the airplane.
Where will they be manufactured? Will that be here in Munich?
Initially, yes, we plan to have up to a rate of 400 aircraft here on site in Munich. And we've just been walking through the production hall where the final assembly takes place. And then later, we intend to go up to 1,000 aircraft per year, but probably with an additional 1 or 2 factories in other markets of the world.
So many questions are kind of leaping around my mind. Pilots, what kind of pilots will be ideal to fly the eVTOLs?
So the European Aviation Agency have already said that it requires normal commercial pilot licenses with a type rating for this specific aircraft, which means you need a couple of hours simulator training for this airplane specifically. And that means they're basically reflecting the simplicity of the automation in the aircraft. They allow a single pilot operation, so you don't have to have 2 pilots because there's a high degree of software automation in the cockpit. And that helps us to have enough pilots available to actually launch the service and not have a shortage of pilots when we go on the market.
And will there be any benefit to looking to helicopter pilots giving the vertical takeoff and landing aspect, or doesn't it really matter?
It can be both. It can be fixed wing or helicopter pilots. What matters most actually is the training pilots have, not so much in controlling the stick of an aircraft. It's much more around all the other activities a pilot does, the flight management, navigation, weather knowledge, all these things is what matters when you're flying an airplane, because our aircraft is so simple to fly that skill on steering the stick is not really the challenge when you fly the aircraft.
No, I got quite close to the London Eye on your simulator at one point.
And you didn't crash into it?
I didn't crash into the London Eye. That would have been simply embarrassing. And vertiports, tell us about vertiports, which is a new word for a lot of people.
Yeah, vertiport is basically a helicopter pad with a charger. So we designed the aircraft to really fit into existing infrastructure, into existing airspace management, into the existing operating rules of aerospace. It's just a different airplane. And the reason this is so important for us is that it enables us then to launch the product on existing infrastructure. That's why the helicopter companies buy our airplane, install a supercharger, and it's a standard automotive supercharger on their landing pad, and they can switch their service using our airplane. So the entry barrier is very low this way. It's an existing operator, there's existing customers, there's existing infrastructure, and an overall regulatory framework that exists in the aerospace industry. And this is the only way you can do it. So the hurdle of entry is really low. If you require new infrastructure or too many new features in regulation, then you make the hurdle ever higher. And the other thing I think that was important for us was how do we get the aerospace supply chain into the project? Because when we founded the company, we felt, will they buy into it? We need their knowledge. And now if you look into the supply chain into this aircraft. Now all the big systems are under contract. You have the who is who of the aerospace supply chain and industry supplying into the program. And for me, that's a wonderful testament of the willingness of this industry to invest into innovation, into green aviation, into electric flight. Otherwise, they wouldn't be on board and invest into delivering into this aircraft. These are like the bricks you have to bring together.
You've had to wear, I would imagine, over the last few years, so many different hats: engineer, designer, architect, businessman. It's been, I would imagine, there've been many lessons on the way, going from a few people and your phrase, your cowboy, did you mention at the beginning? Your kind of cowboy outfit, if you like, to a business with 800 employees. What have you enjoyed the most? What have you found the most difficult about that journey?
I think if I summarize, the biggest challenge was, how do I make sure that I grow at least at the same pace personally as the company is growing? Because as a student, you learn how to deal with engineering formula and how to design something, but everything else you don't learn. Hiring people, managing people, working with suppliers, negotiating, fundraising, all the entrepreneurial side you don't learn. So for me, I always try to learn from the team around me. We hired very capable people, and I was always watching them, trying to learn how they manage people. And at the same time, you of course try to set the culture in the company. And that learning journey, I think, is what is fascinating at the same time. I can only recommend everyone who has a dream, pursue your dream, because you have only one life and it's relatively short. And the learning alongside people and the achieving something in a team together is what is the most exciting thing. People very often look at the aircraft and think that the motivation comes from the airplane. But I have to say, as much as I love the plane, as fascinating as the technology is, the moments that stay as memories in your mind is always the moments with the people. When you achieved something as a team, when you see people dedicating everything they have into that dream that we all share, that's what moved me more. And these are the memories that I have the most in my mind.
It sounds like so far it's been an incredible journey, and it will continue to be a very exciting journey for you. In terms of the actual jet itself, what have been the biggest challenges to overcome?
The biggest challenge, I think, is you can break it down into two buckets. One is the fundamental technical challenge. How do you get an electric engine that can produce 100 kilowatts or 140 horsepower from a weight of 5 kilos? How do you get a battery that delivers the power to keep the aircraft hovering above the ground and lift itself? How do you make that light airframe? These were all engineering challenges on the technology. And then the second big challenge, I would say, is how do you take that technology and design it in an aerospace quality management system, where you have to have full control of your design, of your configuration, your design data. You have to trace your supply chain down to the raw materials. We have to be able to tell you if there's a screw in the aircraft, which batch is it coming from, which material grade is this, what's the torque that screw is going to be torqued with, who was the worker torquing it. All these things are being tracked, and this is what makes sure that airplanes are safe today, that it's the safest means of transportation we have. And that takes so much more discipline and rigor across the company's process landscape and the team working in it. I think that building the aerospace company is almost a bigger challenge than the aircraft itself. It's building that company that can make the airplane and certify it.
And where did the name come from, Daniel, Lilium?
Lilium comes from Otto Lilienthal. So that's a German inventor who around 1900 had this dream that one day we wouldn't be using horse carriages but flying like birds. And he flew himself a lot of gliders. We say he's the first man, at least in Germany, I think, who invented an airplane. And we took his name and translated it into Latin. And we felt we have a similar mission in our minds that fits very well.
And do you still get time to do any personal flying? I mean, you said that you were solo when you were 14, which is extraordinary. I think in the UK, you have to be 16 to fly solo. I mean, 14 is crazily young. Do you still get time to enjoy flying yourself?
Not these days, unfortunately. There was too much work in the company. And as a pilot, you can only fly safely if you fly regularly. But I definitely want to come back to it.
And will you one day fly the Lilium jet, will you qualify as a pilot just so you can experience your own aircraft that you and obviously your team of 800 people have created?
I hope so, that I have the pilot license. I can fly, maybe not with passengers, not as a commercial pilot, but at least for some recreational flights. I would love to do that, yeah.
I'd like to say a big thank you. When I came to fly the simulator today, I knew that I'd perhaps be one of the first people from Britain to fly it. I didn't realise I'd be the first British journalist to fly it, which has absolutely made my day. It was incredible. And I hope that I'll be one of the first passengers when you're flying in Britain. It's been a real joy to chat to you, and I wish you the best of luck with everything you're doing, Daniel.
It was a pleasure. Thanks for having you here.
Did I miss anything out, Daniel? Anything key?
No, I think it was amazing. We covered the whole journey. Perfect.
Brilliant. You've been listening to Daniel Wiegand, founder of aerospace company Lilium and architect of the Lilium jet, the world's first electric vertical takeoff and landing aircraft. Download and subscribe to our series at convex.podbean.com or search The Convex Conversation on Spotify, Stitcher, Apple and Google Podcasts, or wherever you listen to yours. I'll be back on the ground next week with another great guest, so join me then.